submitted, but they actually went out and helped design the sessions and worked with the organizers, got the organizers who then solicited panel members. And so there's a considerable amount of work to put these together. And I think in some respects, I find them incredibly interesting because they tie together the technology that we present in the afternoon with the industry applications and issues in the morning. So stick up a title slide again for, there we go. So this particular session is large language models for consumer technology. And we have two co-moderators. I'll introduce the first one, and he can decide who else he wants to introduce here, since I guess he doesn't want to introduce himself. So we're very, very happy to have Dr. Michael Condrey, who's an IEEE Life Fellow. He's had a number of senior leadership roles within Intel, Sun, AT&T Bell Labs. Within Intel, he retired after being the chief technology officer with Intel's client products division. Michael's held various teaching and research positions with Princeton University, University of Illinois in Champaign-Urbana. His background includes projects in computer architecture, software, firmware, operating systems, networking, Internet of Things, Internet applications, standards, computer security, digital health, and AI. In fact, I guess practically anything you'll find in a modern university's engineering catalog, it seems to be on his resume. Multiple patents, IEEE Industrial Electronics Society Senior AdCom member, past president of IEEE Technology and Engineering Management Society, and he's a board member for our CTSOC. He's a member of the Computer and Engineering Medicine, Biology Sciences, and chair of the IEEE World Technology Summit. We're really delighted that he's going to be moderating and organizing this panel. Michael?
Thank you, Stu. Thank you, Stu. I tend to go for shorter introductions so that people can hear the content rather than long ones, but that's fine. Let's make sure we have the right slide up here. So that yes, thank you very much. Yes, we're gonna have a panel now on large language models and their impact on industry. As a matter of fact, one thing I wish to do is to get CTSOC and industry working together. I've been doing this in other societies, and it's been very successful, and we're going to do that here as well. So I expect to grow the industry footprint and to do more activities where industry can interact and maybe get use of your research, which is a large portion of our membership here. And if you want to be a fellow, if you have companies use your work, that's a lot stronger way of getting there. So having the ability to bridge to industry is very important. So quickly, we have at our conferences, we have industry forum. Starting this year, we're going to have an additional thing. You'll hear about it later. It's an extension of the World Technology Summit where we bring in executives to talk about their challenges, and then you can talk about solutions. But you can talk to the people who have the money and run the companies. But we do have industry forum. And I'll go review that, and then I'm going to turn the microphone over to Matt, my co-chair, and let him talk about the panelists and get the session started. We do have a couple remote panelists, by the way. So Industry Forum is a program that I started in IEEE over 20 years ago. I started in multiple societies, and what we do is we bring experts in from industry to reach out to you and say, okay, this is what we're doing. These are the challenges. This is the issues going on. I've had events where somebody came in with a circuit design, showed the circuit design, and somebody in the audience had a power problem. They raised their hand and they fixed the problem. They shipped product. This is a major win. It's a major win for the researcher. It's a major win for IEEE. We want to do lots more of that. So we talk about where industry is going in technology, standards, and the business side. I mean, having a neat idea is very important, but if you have a wireless charger that zaps my pacemaker, that's not so smart. We have a lot of business challenges to get out, and the product has to sell. So there is a marriage there that we need to work with, and you need to understand, and we need to find the balance of how to make that work. So it's also an opportunity for the research community. I mean, that's mainly the audience, is that they're going to see what industry needs. And I've mentioned before, I think it's most important, if you want to be a fellow, you get your research there and get it used, it's a big win. I can tell you that from being on multiple fellow committees. So with that, I'd like to turn it over to Matt Scott, my ingenious co-chair here, who's done most of the work, and let him give you a little perspective and introduce our speakers.
Thank you, Michael. Welcome, everyone. I'm just going to give a quick teaser of the sort of overview of our topic today, which is large language models in consumer technology. Today and tomorrow. And so we know when we think of large language models and consumer, we think of ChatGPT, one of the fastest growing consumer applications ever. But it's far more than that. Large language models are becoming pervasive in consumer technology. Today, we see them all across the board. If you look at almost any industry, any area, we see them making impact. And if you look, I wrote a list here. We're not going to walk through the whole list, but if you just summarize that list, what we see is that large language models are helping to personalize the technology, personalize medicine, personalize advice, recommendations for you, marketing targeted to consumers at an individual level. We're also seeing the interface being mostly today chatbot related, customer support, chatbots, all throughout this sort of interfacing, it's chatbots. And we're seeing the delivery mechanism today is mostly through apps. That's today. But tomorrow, and I think where it becomes also really interesting, is what's coming next is, on the right side is we have wearables, like second brain wearables, all day augmented sort of heads up display, visual intelligence based on VLMs. We'll have agentic everything. Everything, essentially you have a staff working for you to help you in all things, your home, your work, your life, and autonomous robots, where a robot can be defined as a car, as a household assistant. These are all coming, and the theme we see is autonomy, agents, as opposed to contrast with what we have today, personalization and chatbots. Chatbots is more reactive. I ask and I shall receive, but the future is it's proactive helping me. And it's also shifting from apps to devices, things that you wear, things that you can be transported in. So that's a sort of teaser overview. We'll have our panelists go through more details and speak to this very exciting transformative topic. So I'm super excited to introduce our panelists. These are industry experts, heavyweights from the best companies in the world. I want to introduce them one by one, and then we'll head over into to our session, where each of the individuals will first give an opening talk, and then we'll have a moderated Q&A, and then we'll open it up to questions from the audience. So first, Dr. Alex Cesario, IEEE Fellow. He's a technology luminary with decades of expertise, experience in speech technology, machine learning, conversational systems. As the Siri chief scientist at Apple, he's a leader in advancements in AI-based technologies. He earned numerous prestigious awards and hundreds of patents, textbooks. He has a textbook and hundreds of papers. Rick Talukdar, an AI machine learning expert from AWS, Amazon, 20 years experience. Cloud computing, machine learning. He has large-scale enterprise transformations. He's an architect of AWS Bedrock and a key generative AI initiative for the IEEE. Dr. Lina Karam, who's here in our panel. So we'll have a few panelists remote and some here in person. Dr. Lina Karim, who's here in person. She's an IEEE Fellow, Emerita Professor at ASU, and President of Picaris LLC. She's a renowned world expert in image video processing, computer vision, and machine learning with hundreds of publications, patents, awards, you name it, she's got it. Dr. Robbie Robson, who is here, he's a distinguished researcher, engineer, and entrepreneur. He's a co-founder of EduWorks Corporation and Thea. specializes in AI, large language models. He's a recognized leader in standards, and he has won numerous awards. And Dr. John Apostolopoulos, he's an IEEE fellow, area tech lead for Google Workspace. He's heavily involved in Google's development and rollout of Gen AI for Workspace. He's a distinguished innovator with a career spanning Google, Cisco, HP Labs, and MIT Technology Review's top 100 innovators. Hundreds of patents, papers, again, you name it, he's got it. So without further ado, let's begin our panelists' opening talks. And we're going to interweave here, actually. We'll start with a remote person, and then we'll go to a in-person. And so to start, we'll start with, if we can switch over to Zoom for Dr. Alex Aserio, if that's possible. So this will be a little bit, okay, there he is. So Dr. Aserio, welcome and thank you for your talk. Please start when you're ready.
Thank you very much. It is my great pleasure to be here today. I have to say that I wish I was in Las Vegas. I've been seeing some of the news and all the announcements and videos from the showrooms, and it's really exciting. Last time I was there was in 2012, and we organized a workshop called ESPA, Emerging Signal Processing Applications, as a satellite event to this conference. So I'm very happy to be here today again. Let me tell you a little bit about myself. And start with IEEE. This is an IEEE conference. I've been a member for a long time and volunteering also for many, many years, including things like serving as the president of the IEEE Signal Processing Society. I've been in the board of directors for IEEE, and I'm currently serving in the board of directors for IEEE Foundation and gotten a number of awards. I started my career with a PhD from Carnegie Mellon a long time ago. And then I spent 20 years in Microsoft Research, starting as a researcher in speech technology, then managing a bunch of teams, including speech technology, natural language processing, computer vision, machine learning, communication, audio. And after that, I switched to Apple, where I spent the last 11 years. I was the senior distinguished engineer and city chief scientist for Apple. And it's been like a great ride. I retired from Apple just a few months ago. So now I can spend more time volunteering for IEEE. So now let's start with something that Matt was alluding to. Large language models for consumers. Well, we're not talking about the future. We have the present. And as he was alluding to, ChatGPT already has 300 million weekly active users. That is a lot. And they are sending over 1 billion messages a day. This is not just professional programmers and business users. That's a small fraction of that, although of course those are heavy users. These are consumers. They're asking ChatGPT, well, I'm writing this email. Do you have any suggestions, or can you catch any typos? Can you make it a bit more professional, whatever? Many people using it to help with their homework, answering questions, you name it. Most users type into ChatGPT and get a text response. That's the chatbot interface. But some of them are asking a little bit more adventurous. Well, can you draw me a chart for this? And can you show me an image of that? But most of them are limited to text. And the way this is accessed is the technology is used by consumers, but it's just an app. Most of the time it's an app, or perhaps a website. That's what we have today. And of course, this is just ChatGPT. There is like uses of this, like you can see when you look at Google search, you can get AI overview. You can see that in Bing. You can see that in many other services. So LLMs for consumers is already here. It's not the future, it's already here, and it's growing very fast. Now, this conference about LLMs in consumer electronics, not just consumer technology, but consumer electronics. We're talking about gadgets, some kind of gadget. And you could say, well, an app, yes, does that qualify? An app in my smartphone, my iPad? Yeah, maybe, but probably not what I think most of the people in this conference is interested in. So let me start by telling you some of the work that I was involved a couple of years ago when we started thinking, well, this LLM thing is big. So can we run them on device? And there was an announcement at the Worldwide Developers Conference last year that iPhones can run small LLMs. I know it's a kind of a contradictory, having the word small and the word large next to each other, but small up to 3 billion parameters natively on an iPhone without having real time. You don't need to like wait until it loads or anything. And that's because it leverages hardware acceleration in the silicon, like the Apple Neural Engine. So this is something that is technologically not easy to do. There was a lot of optimizations done to make that happen. Now you may argue, why do you want to do that? Do you just want to do it because you can? What's wrong with just using the ChatGPT app, for example? Well, there are some things that you can do, like for instance, email summarization or write assistance that you could do perfectly fine on your device, on your phone, let's say, without having to send it to the cloud. So that has the advantage of increased privacy, more reliability, it may be faster. So there's a number of advantages in doing that. You can still, it's not like you can still send this to the cloud if you want. It'll be burning more forests. All of the GPUs are consuming an enormous amount of energy out there. So this would be more efficient, but it's an option. But the most interesting thing is this is not just about a chat interface, not just you type something into the app and you get some text back, but it also does things for you. And we're talking about agents. This is something like people are now calling, if it does more than just talk back and it does something for you, that's an agent. There are different definitions, but for example, the LLM in the Apple software, the Apple Intelligence as it's called, outputs app intents, which is essentially a type of iOS function calls to control apps. If you think about it, this is not surprising because you can ask ChatGPT to write a program for you, and it can do, and you tell it, I want a program that does this, and it can write code. So this is kind of like customized code. So you can fine tune a standard LLM to learn how to turn on the flashlight or send a message. So not just talk, but do something for you. It can also result in more conversational Siri. One of the things that is what I think the superpowers of the LLMs is that keep track of context. This thing that you said 3 turns ago, it still remembers. And that's something that historically was very difficult to do. Genmojis and many other approaches. But one of the things that is key is that you can personalize this. How valuable it's an assistant, a digital assistant, if that assistant knows you. Much more valuable than if it doesn't. Now, it doesn't mean there is no value if it is like a generic, but there's definitely more value when you hire an assistant, a human assistant, from day one until that assistant gets to know you. And then you can get more value out of it. So you can personalize it. You may know what is in your calendar, who are your contacts, what are the text message that you just got, what is on your screen, all that information, and that's plugged in. And then last, privacy. Well, you could do all of these things on a server base. You could. And then it's just a matter of like, are you comfortable sending, I want to reply to John's message and have that sent? You know, some people may be okay. This is more reliable. Again, it's more efficient. So that's why this was launched. And that's just one example. And we can talk about that later if that comes up. But of course, there's a lot more opportunities, and this is, people are working on it, but I don't think it's quite there yet. That is very exciting in consumer electronics. Let's say that you have like a security camera. This is just an example. Well, security cameras have improved a lot over the last few years. I mean, it used to be that you can barely see, the resolution was really bad. Now resolution is really good. You can see there's a car, so that's the license plate. You couldn't do that now. Now, the problem with that is that it's not very valuable if you just get a raw stream, because what are you going to do with it? Watch it all the time? So a lot of these security cameras have like some detectors, or there's a motion detector. Maybe some of them are getting fancier and detect, okay, I think there's a face. That's better because now you record just snippets. But imagine if it was doing like a person would do. Oh, don't worry about that. That's a little Joey playing in the backyard. You don't need to send me an alert. I know him. It's fine. Everything is playing with the ball. No problem. As opposed to, who's that person there? I've never seen that person. It's not the landscapers. The landscapers come on Mondays, and this is not. It's not. I don't see a label saying that this is an Amazon or UPS delivery. Maybe something to alert my user. That technology personalization is something that you could use. LLMs are, at least in a broad way, these foundation models, which is not just language or the text language, but also verbal. You have all these robots. These robots don't know anything about your house, but imagine if they're vacuum and they know, oh, there's a step here. Oh, this is the part that is usually dirty. That's where the kids play and drop all the breadcrumbs. That's when I need to go first. You could personalize it. That would be exciting and valuable. And of course, we have these humanoid robots that are around the corner, and they could do a lot of things. And it's much better if they know your house, if they know who lives there, and they're personalized. So there's an opportunity. Then you have all these wearables, and a lot of this has to do with like health related sensors that you can see, or like smart glasses. Imagine if it is personalized and it knows that I'm talking to someone, and I say, well, remind me where Brick works next time I see him. And I'm looking at it. So the system can record just that. And next time I see him, oh, his name is Rick Talukdar, for example. All of these things are exciting opportunities, and the future is going to be great. This is one of these transformations that we get that ranks together with that the upcoming of the personal computer, the internet, the iPhone, the web, the e-commerce, and then we have these large language models or foundation models. That's great. Thank you.
Thank you, Dr. Serio, for the great opening talk. Now we're going to, again, interweave, so we're going to have a in-person panelist. I'd like to ask Dr. Robbie Robson to come up here and give his opening talk. Thank you.
Okay, hi. Hello? Hello? Hi, are we all awake? Okay, good. That's good. So I'm Robbie Robson. Just a little bit about my background. My first career was in mathematics, in real algebraic geometry, and computational number theory. I left that to start a company that is in educational technology, although really more in training technology. And I'm going to take you through my journey that led up to also founding a recent company that focuses on industrial applications of AI. I'm also involved in standards. I'm on the standards board and have been on the board of governors of the Standards Association and have been involved in many standardization efforts. So how did I get here? So first of all, we started back in the 1990s looking at problems like automated metadata generation. And the large language models, the middle word there is language. And so we were always involved in dealing with what was then called computational linguistics. So the first things was something called latent semantic analysis, which made a big hit in the 1990s because it could be used to automatically grade essays, and better, with more reliability and better than teaching assistants. So even that back then had some implications. We moved into things called intelligent tutoring systems. They're now called adaptive instructional systems, using techniques like Dirichlet analysis.
So if you want to make
This
yourself
was in the
comfortable, get a drink of water, use the
2000s,
restroom,
and moved on to
this is
things like
opportunity.
automated
You can
question
sit around, get
generation, which we thought was going to be
until the next presenter.
have a huge impact, and it didn't. But nonetheless, we developed a bunch of semantic, syntactic things, and we ended up looking at a very concrete problem in the I guess it's a worldwide problem, but this one was particularly in the United States, which had to do with workforce development. And we were interested in figuring out how to, and I know sounds a long ways from consumer technology, but we were interested in trying to figure out how to connect colleges to industry for upskilling workers and understanding what skills they needed and so forth. And so this was just when transformers, which are what large language models are, started to come out. This was right after Attention is All You Need paper, and we started using transformers to extract skills from job descriptions. And I mention these kinds of things because these are extremely concrete examples of how some of this technology is used. They're not abstract at all. We're trying to figure out how to do that. And in that process, we eventually had to solve a bunch of very, very concrete problems. One of which was that it was too expensive for us. We are not, there are some people here from Amazon and Google and Apple. We are not the size of Amazon and Google and Apple. Cost is a huge issue for running applications. So we had to figure out how to make what was just called small large language models, and how to run these things on small platforms that weren't in huge data centers, and eventually got to the point where we created a platform, and the name of that platform is Thea. It has a lot of different aspects to it. It includes sort of automated query expansion, automated prompt engineering, if you would, a lot of self-regulation, uses a lot of techniques that I'm not going to go into the technical details of, but the upshot is that it can run on like a single H100. You can do the equivalent of many things that ChatGPT is doing at that scale. And in addition, it can take data from a lot of different sources. And with that, I'm going to talk about a few just thoughts that I have about where this technology is going. So first of all, it was already mentioned the technology is becoming multi-agentic technology. And it is incredibly important that the technology that is applied in consumer applications be able to get data from a lot of different kinds of sources, not simply language data, or it could be video data. It could also be SQL. It can be tabular data. There's lots and lots of different kinds of data. And one of the applications that we've built with our platform, for example, is predicting when a company is going to be in financial difficulty. And these are the kinds of predictions, and that you need to have data from very many different places and of very many different kinds that these models can put together. The most language models these days, ChatGPT, et cetera, are used for question answering or for querying. But to me, that's not where consumer technology, or in fact LLMs in general and machine learning in general, is going. Predictive analytics is probably far more important, and we're starting to see concierge services. It's funny, I actually did the slide together, and 2 days later got the email from, I think it was Delta Airlines, on their concierge service that they used the word. But the idea of being able to look at your personal data and help you navigate your world in a personalized way is just really, really powerful. The other thing that they can do is coach. So how many of you play League of Legends? How many of you are Riot Games folks? Not many. Wow. Okay, I was expecting more. All right. So one of our applications is a coach that coaches strategy for. In this case, it's a related game, but the coaches game strategy. So the kind of interesting applications for consumers are making your world better and also helping you understand and learning things a lot faster. There's two more things. I've mentioned sort of the edge plus 6G, and that was mentioned in the last talk. And if we think about the fact that an Apple iPhone, as was mentioned, can have a 3 billion parameter model, the models that we use in our industrial applications range from about 3 to 7 billion parameters. So it's in that area that we're looking at. And but the data that has to come from a lot of sources. So I think as 6G gets developed, there's going to be a very interesting synergy between the ability to do edge computing on a device and the ability to rapidly get data to update things. And one of the techniques that's incredibly important is the ability to update models quickly with techniques like low rank adaptation and things like that that don't involve retraining the models themselves. So a lot of that is what's happening in LLMs. The last thing I'm going to leave you with is something that my son has often talked to me about, and that is that what happens when we get these devices that allow you to see better, that allow you to hear better, that allow you to walk better, to be more powerful, but only developed countries, only wealthy people can afford them. What does that do? And do we have a responsibility to think about how not only the technology, but the dispersion of the technology? And I mean, the gap between what somebody with a phone, all of you, I suspect, have a phone in your pocket, perhaps even you're looking at it now, and what you can do with that phone versus what you could do with what are they called? The classic phones, the old ones that just are phones, is just amazing, the amount of information that you carry. But what if now you can also see better because you have bionic eyes? If you can see ultraviolet, it's the last time you'll ever want to go into a hotel room. But the thing is that you'll be able to see better than people that don't. You'll be able to hear better, etc. We were at a concert last night, and Michael was able to turn down the volume literally on his phone. I mean, these kinds of things are quite powerful, and when you add LLMs and current machine learning into the mix, it's something that we really do need to think about what this is in the future. The last remark I'm going to make is I said I was involved in standards, and this is just sort of an advertisement. I just wanted to point out that, especially since Michael's one of the moderators, that there are numerous IEEE standards being developed that are relevant to large language models, machine learning, issues of bias, issues of quality, issues of secure computing, which is secure multi-party computing, the kind of thing that we were talking about of data from different people going up into the cloud and getting put into joint models, et cetera. And if you're interested, this is a great place to work and to learn about some of the technology, but also to contribute. So thanks very much.
Thank you, Robbie. Yes.
I guess it doesn't. Anyway, I was going to add that my watch also told me how loud it was, in addition to the ability to control my hearing aid.
Perfect. Thank you, Michael. Okay, so for next, we're going to switch back to remote for one of our other remote esteemed panelists, Dr. John Apostolopoulos, if we can have him on Zoom.
Hello, can you hear me?
Yes.
Excellent. So what I'm going to do now is also share some slides. Great. So hopefully you can see my slides. And first of all, I wanted to thank the moderators for your kind invitation for me to join you. It's a privilege being part of the panel and helping share my thoughts with all of you, and also to get your feedback. As I think back, the first time I actually attended ICCE was, I think, in 1994, when I gave a presentation on an effort we did, a project system we built for the USD-TV standard. So it's been many years, and it's great being back here. So thank you. So I'm going to talk today about 3 design principles for using LLMs in computer technology. And in particular, I'm going to talk about 3 different problems. And for each problem, the design principle I would like to recommend. Okay, so first let me describe what the 3 problems are. So I'll have 1 slide on each, and the problem's in the title here. So the first one is, how can we improve how users interact with consumer devices? The second is, when should we use LLMs? And the third is, where should we run the LLMs, in the cloud or the user device? Okay, let's go through these now. So first of all, the first problem is how to improve how users interact with consumer devices. And you'll see here, there's a lot of things I mentioned which basically will resonate with the key points that Alex had mentioned before. And as we remember, consumer devices used to have remotes, and then they moved to speech recognition, and that was a big step forward. I think with LLMs, what we can do is we can do a much better job in terms of understanding what is the user intent. But that is, what does the user intend to do? So as you see here, where I show this consumer device in this blue box, we have an LLM. It provides the user intent, and then that user intent leads to the processing. What happens is, I believe, the more accurately we can identify what the user's intent is, the more accurately we can do the desired processing, and the happier the user will be. Now, the reason LLMs are an advancement over prior speech recognition techniques is that they include a sophisticated language model that can better understand what the user is trying to say. So, for example, I may say the same idea, the same request, with many different sentences, many different types of sentences. And the LLM will hopefully identify that all these different ways of expressing what I want to do actually mean the same thing. So I can express it using natural language understanding. I mean, the LLM could help with natural language understanding. In addition, there is a conversational interaction that occurs here, a multi-turn thing. So after I say something, the LLM could ask to clarifying questions, just like a human would. This multi-turn approach can dramatically improve the consumer's device's ability to understand what the user is trying to do. We'll also have very soon, I mean, we're beginning to have them already, image and video inputs for this that are incredibly powerful. Let's say I have home automation and I say, please turn off that light there. Well, by the consumer device being able to hear and understand my language and also see what I'm pointing at and know where I'm in the room, it can identify which specific device to turn off, which specific light to turn off, even if I can't verbally describe which light that is. Okay, so basically we can interact with a consumer device similar to the way you would interact with a human who's able to hear what you hear, see what you see, so forth. And also, as was mentioned by colleagues like Alex, we can have improved personalization based on the history of what the user wants to do. And we can support agent-based capabilities in the future. So the main takeaway here is that I think we can help improve how users interact with consumer devices by really focusing our LLM efforts on better understanding the user's intent. I mean, this is naturally something that we kind of do, but if we really focus on truly understanding as accurately as possible the user's intent, the consumer device can make the user much more happy, satisfied, and so forth. The second problem is, when should we use LLMs? Now, as we know, LLMs are incredibly powerful. They are also generically useful to address a variety of different problems. And they're improving rapidly. Every month, the LLMs are getting better and better. However, as we also know, they often have problems. Okay, they can make mistakes. We've all heard about these really terrible hallucinations that have occurred, and we need to try to prevent errors like that. Notice that an error could occur because the LLM makes an error, or because the human made an error. Maybe I said something incorrectly. I didn't actually say what I intended. I said something different. The LLM accurately identified what I said, but that wasn't what I intended. That can also lead to an error, which would be very frustrating for the user. So the recommendation that I want to stress here, and this is something many of you may already do, but if you don't already do it, I think it's worth considering, is to focus on very specific, valuable use cases. And by specific, I mean try to narrow down the use case so that you can really understand what the requests will be, what the usage will be, and very importantly, what the errors could be too. And then you want to investigate those errors and identify, are they bad? Also understand, are these errors easy for the user to see and to recover from? Because if they're easy for the user to see and recover from, then the user can overcome those errors and they're not as, let's say, it's catastrophic for the user. On the other hand, if the if the user cannot tell that an error has occurred until much, much later, or if they can't recover from that, in both those cases, the user will get very frustrated and may never use that capability again. And then, of course, you want to gather user feedback with various trials, iterate to improve, and so forth. The iteration is incredibly important to do. So the design principle I want to stress here is to design products for use cases that are valuable and non-fragile. And by non-fragile, I mean where the errors should be easy to see and easy to recover from. And easy for the user to see, not for the engineer who built it. Easy for the user to see and to recover from. Now, the third topic is where to run the LLM. Of course, today we run it primarily in the cloud. But as was mentioned by my colleagues, we're doing more and more on user devices. And there are a lot of tailwinds that are helping us run them even better on user devices. For example, for instance, Alex mentioned, the LLMs are getting smaller in size while still having better and better capabilities. And all the major chip makers are optimizing their chips, their GPUs, and so forth for LLMs. So sometimes these are called neural processing units, sometimes they're called tensor processing units, sometimes they're GPUs with calls to support the LLM, or CPUs with calls to support the LLM. But there's a lot of work from the silicon all the way up to support the LLMs on smaller and smaller devices. Now, there's still many trade-offs on where to run the LLM. And I try to highlight some of these trade-offs in the table on the right. So in the table there, what you see is I have various attributes which may be important for your use case. And then I try to show, are these attributes, for example, is cloud strong at the attribute or is it weak at the attribute? Same thing for on device. I use green to show a strength and red to show a potential weakness. As an example, quality. If quality is the most important thing for your use case, you probably want a very sophisticated, powerful LLM to help you. Usually those LLMs are run in the cloud, so this is the strength of the cloud, and they're harder to run on device, so this may be a weakness for the device. Another key area is manageability. As you know, these LLMs are improving almost monthly, so you'd like to update them frequently. In the cloud, it's very easy to update an LLM. On device, it's much harder because, for example, for this device here, I have to the user has to take an action to upgrade it, or it may take an action depending on the way it's set up. So manageability is often harder on the device. If you look at another set of cases, let's say scale. Let's say you have a very popular service or which tens of millions of people may want to use it at the same time. Then the scale of the infrastructure you need to support that in the cloud may be prohibitive. Okay, so as you get to larger and larger scale, this may be a weakness for the cloud, but it may be a strength for doing it on device. Similarly, let's say you don't have a huge number of people using your service at any specific point in time, but you have continuous usage. And there's a cost per use. And if you add up that cost over a large length of time, it still could be prohibitive. That may also lead to a case where you may not want to do it in the cloud. Well, if you do it on device, you may not have that associated cost. So on the left here, I have some questions which may help in your thinking about for your use case. What should you be doing? What is the preferred architecture? So the first question is the natural one. Does on-device make sense for your use case? And part of this relates to what is a device that you may leverage here. So for example, if you're talking about computing devices like phones, iPads, laptops, desktops, it's natural for they may have a LLM on device, it's natural to use it. If you have a wearable like smart glasses or a fitness wearable or a health wearable, well, maybe that device does not have a built-in LLM, but maybe it can leverage over wireless your cell phone or a desktop or a laptop. Now the question comes up, how about your smart TV or your smart house? In that case, do you want to leverage, should you have an LLM built into the smart house infrastructure? Should it leverage the LLM of your laptop or your mobile device or your desktop, or should it leverage the cloud? There are a lot of interesting questions here that depend a lot on the specific use case. Second big area is, where do the LLM function calls go? Because often the LLM is part of a processing chain. Use the LLM to understand what the user wants to do, and then to perform various actions. And those as part of that pipeline, you may need to, for example, look at data that's stored somewhere. The data may be stored on device or may be stored in the cloud. That may affect how you architect the system. Also, does it need to go out to the internet to gather additional information, for example, weather information? So that may also affect what sort of architecture you do. In addition, does hybrid bring value? And by hybrid, what I mean is trying to decompose the processing across the device and the cloud. As an example, you may have the LLM processing on device, but you may have a lot of the subsequent processing, storage, and actions taken by things in the cloud. Alternatively, you may have a small LLM run on device that can handle many relatively narrow-defined use cases. And then when a more complicated use case comes up, that request could actually go to a more sophisticated LLM in the cloud. So the cloud then would complement the capabilities of the on-device LLM. You could have two LLMs, a small one on device, a larger one in the cloud. And basically, depending on what you try to do, you route the request to the particular LLM. Okay. So the design principle here I want to stress is that depending on your use case, you want to investigate which is the preferred architecture. Should it be done on device? Should it be done in the cloud? Should we split the processing across both of these? And also, how does this change over time? Because what is the preferred architecture for today is probably different than 1 year from now or 2 years from now. As we look 1, 2, 3 years down the road, the use of these sort of capabilities locally to the user will probably dramatically increase. Yeah, thank you, and I'm happy to discuss any of these topics further in our panel. Thank you.
Perfect. Thank you, Dr. Thank you, John. So it was a very good opening talk. Let's now head over to Dr. Lina Karam, who will present her opening talk.
Thank you. Hello, everybody. I hope you're still awake. I'm very happy to be here. You know, I'd like to a little bit state some things about myself, especially I think we have people here mixed from academia and industry. And my experience with industry started a long time when I was a graduate student by doing internships. And one of them in particular, where I worked on image and video compression products at AT&T Bell Labs, where I met also John, who just talked, my colleague. So it's good to have these to network and so forth. And from that, I went to academia, where I raised to the rank of full professor at Arizona State University. I got my IEEE fellowship. But even in academia, I was still working very actively with industry. Very important to lead collaborative R&D with industry, also productization. So we had like products on image video and computer vision and machine learning adopted, and actively were involved in the productization with Motorola, General Dynamics, Intel, smart manufacturing, and also advanced driver assist system that were presented at CES here. And currently, later, you know, I wanted to have other experiences, so went overseas as Dean of Engineering in the Middle East. I was the first woman Dean of Engineering. And when I came back to the US, I said, hey, I like to have these new experiences. I moved to industry, holding an emerita professor's position at ASU, but working in industry. So I helped co-found a company in AI, but for a specialized domain, architecture, engineering, and construction. It's a specialized domain with different rules, regulations, etc. You know, you have to specify states, cities, regulation for land development, and so forth. So I'm working there, leading R&D and product development for AI machine learning and generative AI for the specialized domain, in addition to also doing some expert consulting on that. That said, with this intro, one thing that's important you see across the talk, and they made my life easier, introducing all the different application stuff, is when we say we want to improve the user experience, we want to improve the quality. But how do you measure the quality? How do you measure that you improve the user experience? One question John asked, on-device versus the cloud. If to make that, which one for your application would improve the user experience? Would the on-device improve the user experience, or the cloud would improve the user experience? How do you assess and measure that? And this is kind of the subject of this talk, the importance of quality assessment of large language models, especially when we want to deploy those at scale in consumer technologies. We know that consumer technologies are ubiquitous and everywhere, and they support a variety of applications, as my co-panelists talked about. And deploying those at scale in consumer technologies would make those available and easily accessible by a wide base of users with different level of knowledge, different ages, from children, teenagers, to seniors, and different expertise, novice, beginners, users, in addition to experts. So therefore, it's a responsibility for us to make sure that these LLM have quality, guaranteed quality, and especially they're getting increasingly used for information extraction, knowledge discovery, and also critical decision making by users. And John, my colleague, talked about recognizing errors as feedback. Some users can recognize other errors, others no, would take for granted that this LLM knows what it's doing. So we need to make sure we have quality assessment methodologies that would ensure that we have how to measure that our LLM is meeting the quality guarantees in terms of accuracy, reliability, security, in terms of resilience to attacks, and also efficiency in critical applications. You have some applications that critical real-time, you want to guarantee efficiency, and plus how to measure that we're not degrading the user experience, actually enhancing it. Otherwise, there is no point of having an LLM if you're degrading the user experience. So quality assessment is very important to guarantee that. In addition, quality assessment can be used for a particular application to compare different LLM models to know which one is suitable for your task, and which model is suitable for that. In addition, quality assessment can be used as a diagnostic tool. If your performance degraded for some reason and something is happening, you need to know why. What's the reason of the degradation? Is it the LLM model or something else? So use the quality assessment also as a diagnostic tool to fix what's happening. So that said, there are many quality factors that can affect the quality of LLM. These include the data sources we're using, the model, the size, the architecture, and also the computing infrastructure that we have. In addition, the user expectation and perceptions, depending on their level of knowledge, their age, etc., can affect the quality. And that's why one thing is we want to enhance the user experience by providing different input-output modalities. Is that application requiring a single modality? Does it require an augmented modality? For example, is it only text-based? Even in text-based, you have document including figures. Can it understand that? Does it understand different modalities, audio, speech? For the output modality, can it adapt to the user needs to do that? Would you have, so the level of interaction in terms of human-computer interfaces and natural user interface or interactions. And also one thing that affects the quality is the domain knowledge, the level of expertise you require for a certain domain. For example, just to a simple example to illustrate that. So these are two sample LLM-based framework. In the first top one, you could see that we have here an LLM model that was trained for general word knowledge, so general knowledge over wide data sets. So if you ask a question in a specialized domain that requires special expertise, for example, medical, specialized healthcare sector that requires some specialized expertise, in addition to requiring regulations and processes and stuff, then this top system with this general knowledge LLM is not going to perform well. So you have to match it better to your domain of expertise. And that's why, for example, the bottom system, you could take that LLM, retrain it, which is time consuming, requiring a lot of time and resources. Another framework is to augment your query with relevant sources, data sources relevant to your specialized domain, and train what we call a retriever, and that's the retriever augmented generation framework, where that retriever, you train it based on your query, to find the relevant context from the data that's matched to your domain and augment your query with it, and then feed it, to your LLM. And this would improve the performance of the LLM. But even in this system, the second system, if for some reason the performance degrades, or if you want to do quality assessment, suppose you find the quality is not satisfactory, you want to know why. So in this case, you can do, maybe it's the retriever not working and not generating the relevant context. So quality assessment can be applied locally to different components to know which one needs to be improved and how you want to modify the system. You can have adversarial attacks to the input. If you ask a question, it gets attacked and changed, you get a different response. You can have attack to the models, to the data. So you need to know how to assess that. So quality assessment can be done in two different forms. Subjectively, this requires human intervention, human experts looking and seeing and verifying the quality. And it can be done objectively through automated measures that you develop, and implement in software or hardware, or whatever you want, integrate in your consumer electronic devices. For example, in your TVs that you have at home, there is a quality assessment, chip inside the TV or software running inside the TV to determine the quality of the image, and it improves it for you. You see, by software instead. So you have that. So you could integrate now some quality assessment there, automated to also assess your LLM or multimodal LLM that can be automated. And these quality measures can be reference-based, where when you're doing the assessment, you have the ground truth based on a benchmark to assess the quality of the model, or it can be reference-less, where you don't have the ground truth. You just have the queries that you want to test and validate, or use cases. In this case, you could train another LLM as a judge. So another LLM as a judge to tell you whether the quality of the LLM you're using. That said, to train that second LLM, it should match the human expertise performance. So subjective quality assessment can be time consuming, but it's essential and needed to validate the objective metric before you use them, that they can match the human subjective performance. And also an essential thing is how to construct valid benchmarks and data sets. So your benchmark, you could have a benchmark or data set which are validation test cases or validation data to assess the performance, but you could tweak your benchmark, to show that your model is better. You see, so we have to know how to design appropriate benchmarks that are fair to assess the performance of different LLM. And this is where standardization is needed. Standards, you have experts coming together to define what's the best process to ensure that quality assessment is done in a consistent, fair, and systematic way. So how to construct good, suitable benchmarks for your assessment, depending on your application. These benchmarks can change for sure. For the subjective assessment, what's the minimum number of experts you need, or humans, or non-experts even? It depends on the quality assessment tasks, the minimum number, the session duration, the level of expertise, the environment, is it crowdsourcing versus controlled setup, and so forth. For the objective quality assessment, how do you validate, what's the process to validate that a measure, automated measure, is working to assess the quality of your LLM-based system? And also, what are good characteristics of these measures for various tasks and application? So thank you, and this is my LinkedIn profile if you want to connect with me, and you can ask me your questions there. Definitely will take your questions here, but if afterwards you have other questions, please feel free to connect, and I'll be happy to answer those. Thank you very much.
Thank you, Lina. Thank you, Lina. Okay, and our last opening talk is from a remote panelist, Rick Talukdar. If we can have him from Zoom. Okay.
Mr. Rick, you need to unmute if you can.
Well, we cannot hear Rick. Okay.
Hi, sorry about it. I was trying to find my unmute button. Now I guess I'm audible. Perfect. Thank you so much. Good morning, folks. Again, I'm super excited to be here. Thank you for the invitation. And thank you again to the panelists for their impressive and eye-opening talks. Now, let me start by trying to picture this. Let's say it's 7 a.m. in the morning and you are wearing your wearables, which whispers personalized health advice to you based on your last night's sleep. As you commute to your office, your assistant reminds you of your meetings. And not only does that, it actually adjusts the calendar based on the weather pattern and traffic patterns. When you get back home, your smart devices anticipates your mood and then dims the light and plays the music. This isn't it a fiction anymore. It's the power of the large language models architected in the cloud, which is reshaping our experiences every day. My name is Rick Talukdar. I'm a senior IEEE member and an AML architect focused on innovation and research. Today, I'm going to take you back and look at some of the architectural patterns that we see across and how these experiences are delivered across consumer tech. Let's first explore some of the real-life examples. If you refer to the Google assistants my fellow panelists were mentioning, millions of devices are served every day across the globe. It's powered by Edge Cloud Synergy. Netflix uses and serves millions of customers globally. And they do it by dynamically scaling their large language model workloads to provide instant recommendations. Wearables like Fitbit, they have on-device AI while they send out long-term insight data for the cloud. Amazon's Alexa handles billions of interactions weekly. They do it by using serverless computing and multi-region deployments, which scales automatically based on the demand. Now, these innovations certainly demonstrate the transformative potential of LLMs. But beneath the surface lies the challenges that we must tackle. If we look at some of the common challenges that we see, the topmost challenge is that LLMs are highly resource intensive. It requires significant computational power and storage, which basically translates to high cost for training, for tuning, for deploying this model and running inferences. For consumer tech, this remains as a consistent and a key challenge. Now, if you look at performance, LLMs certainly demonstrate remarkable performances and capabilities. But achieving all these performances consistently across a diverse set of use cases and devices is complex. Often, you heard my fellow panelists referring to tuning, domain training, but these requires trade-offs between accuracy, speed, and robustness. The other key challenge that we come across is scalability. Imagine handling millions of requests simultaneously. This certainly introduces bottlenecks. Then you're referring to real-time responsiveness. Imagine peak usage. This can certainly be hindered and bottlenecked by latency, as well as other hardware and infrastructural issues. The other key aspect that we're seeing is sustainability and ethical AI. Certainly, as you saw, the carbon footprint for training LLM is not low. It's actually significantly high. Additionally, ensuring the ethical practices such as fairness, bias, transparency is critical for the consumer to build that trust and meet the regulatory requirements. So the question that I pose is, how do you architect? How do you architect considering all these challenges? What I feel, balancing innovation with sustainability is the key here. The answer lies in smart architectural patterns. Now, to look at this, I have put forward some common patterns that we see across. One of the pattern is edge computing with cloud. So the edge handles the real-time tasks on devices, which helps to reduce the latency, and the cloud manages the computationally intensive tasks. For example, refer to Amazon Echo. It processes the wake words locally while querying the cloud for any complex responses. The advantage of this pattern is certainly low latency for any time-sensitive tasks, and then the power of cloud with the scalability and storage. The other pattern that we see is the federated learning architecture. Now, this is where the devices actually collaboratively learn from a distributed data while they maintain the privacy. You have the option to update the models locally in the device. And then the federated aggregation actually helps to consolidate insights across devices globally. The advantage is certainly stronger privacy guarantees, and it helps to reduce network bandwidth usage. The other common architectural pattern in the cloud we see is serverless architecture. Now, serverless computing actually helps to dynamically allocate resources based on demand. Often these are termed as event-driven workflows, which optimize resource usage. The advantage certainly we see is scalability, high scalability and cost efficiency. And then it provides the simplified deployment and maintenance options. With the power of generative AI, there are certainly new architectural patterns that are evolving as we speak. Generative AI-powered architectures. And these are real-time creation and customization. Imagine you're providing a personal recommendation based on certain workout plans, or maybe based on the recipes that are being generated as an assistant. These are tailored experiences, which is based on user preferences. The advantage of this architecture is certainly it provides enhanced user engagement and personalization. At the same time, imagine you have to scale this customized experience across millions of devices. Finally, we are looking at agentic architectures or multi-agent architectures. Agentic architectures are autonomous architectures which can perceive, which can reason, and which can act based on context. So the contextual understanding and proactive decision-making is a key part of these agentic architectures. Certainly the advantage of these architectures are reduced user intervention, greater adaptability, and more dynamic capabilities to handle situations. Now, by leveraging these architectures, you can actually optimize for efficiency, for scalability, and more personalized and curated experience for user. With that, the evolving architectural patterns, we see a symmetry in the consumer electronics, which actually reflects the growing demand for more and more personalized and scalable need. I feel these are not just innovation. These are actually shaping the future of consumer electronics. So what does this mean for us? Actually, architecting cloud for the cloud is not just about infrastructure. What I think is it's about redefining the consumer experience, making it more personalized, more curated, scalable, and equally sustainable. But what we think, can we stop here? As architects, as engineers and leaders, I think it's time to push the boundaries, to innovate responsibly, optimize thoughtfully, and scale. I feel the tools and the technology is here. The demand is growing. But the question is how far we can take it. Let's shape a future where technology isn't about being smart. It's intuitive, inclusive, and impactful. Let's build together. With that, let me hand it over to Matt. Thank you.
Perfect. Thank you, Rick. That was great. Okay, so now in this next section of the session here, we're going to go through Q&A. We're going to start with moderated Q&A. So I will be asking questions to the panelists, and due to the sake of time, I'll do sort of one-to-one, one question for one panelist, and then we'll head over to the audience. So I'm going to start off with a question for Dr. John Apostolopoulos that is, in the future, we may have many LLMs or AIs in one's home. with potentially overlapping capabilities and controls. The question is, how can we orchestrate across these various brains to have an enjoyable, predictable, and consistent experience? John?
Yes, thanks, Matt. That's a great question. I kind of view that as the AI analog of what we often had in the past, where we had, let's say, an AV system, but we had multiple remotes. And because we had multiple remotes, it often got quite complicated in terms of controlling the system. You can think about it there that each of the remote was a separate brain, and you had to get these brains aligned in order to get it, or controller brain, choose your analogy, to get the desired outcome. The same thing can very easily happen in the future with us, where even if we try to use LLMs on device, my wife has an Apple iPhone. I have an Android iPhone. My daughter has a different device. We have an Amazon Echo at home. So we have quite a few capabilities, right, as you heard right there, in terms of LLMs. So I think this is a really important problem. I don't actually have good insights about how to solve it, but I think this is something where, as an industry, we have to look at how can we make it easier if there are potentially multiple AIs that can control things in the home, to get them to orchestrate themselves well together in order to achieve the desired outcome. So this is something that I believe us as an industry need to work together on to try to address this problem.
That's great. Okay, so the next question is we addressed it lightly, but I want to double click on it. And this is a question for Dr. Alex Cesario. What are the most promising applications of large language models in consumer technology that are not yet mainstream? We have a whole bunch of mainstream already, but what is not mainstream? What's the future? If we can sort of just double click on that. It's hard to predict the future, but Alex has been working on the future for so long. So maybe, Alex, you can give us some insights.
Well, I'm afraid I didn't bring my crystal ball with me, so I cannot predict the future. But I mentioned a few of those possible applications in my opening remarks, where I think that the fact that you can have multimodal inputs and outputs in a foundation model can make the whole more than the sum of the parts. And the fact that you can personalize it. So again, whether it's your vacuum cleaner, the new Roomba lookalike, that knows your house and it knows where it cannot go and it knows where it gets dirty, that's something that could be very valuable. Or some wearable that you have that is checking your health and is keeping you healthy because it knows what's normal and what isn't. It's also seen, maybe pair up with your smart glasses. So it has a lot of information, lots of context. And I think that I'm surprised. I'm participating with a venture capital firm, and we review startups in AI. And every day we see something like, wow, I had not thought of that. So this is a great space. If you have a problem, don't think LLMs is always the answer, but it might be in some cases. It's very exciting.
Awesome. Thank you, Alex. Okay, so the next question I'd like to address to Dr. Robbie Robson. The question is, what role should regulation play in the development and deployment of large language models in consumer products?
How do I? Okay. Yeah. So thanks for the question. The regulatory environment is certainly in flux right now, and I mean I personally think that in many ways standardization, I will remark, is more important than regulation. Standards do become regulatory, but I think the biggest thing is how much of your private data are you willing to share? When we talk about these on-device LLMs, they are being trained on the device as well as in the cloud. And so they're learning an awful lot about you. And I think just like in GDPR and other areas like that, that at some point we're going to need to have control over what data we share and under what circumstances we share it. And I think that those are some of the, quite frankly, IEEE standards that are being and will be developed that will play very important roles in those regards.
Perfect. Thank you, Robbie. The next question I'd like to direct to Dr. Lina Karam. The question is, how can the industry address concerns about AI bias and transparency in consumer large language model applications?
Yeah, I mean, I'll hold it down. Can you hear me? Okay. Yeah, this is really very interesting question and controversial. I mean, if you want to reduce the bias, you have to assess the bias. And this brings us to the quality assessment also. You could kind of have quality metrics to measure bias, and you have the benchmark for it to measure bias and transparency, and maybe fix that. But that said, if that LLM is learning from the society, and if the society has bias, do you want to just eliminate and ignore that and have that perfect LLM reflecting in other society? I mean, that's why I say it's controversial. I mean, do you want your LLM to show you that bias, but then maybe fix it, tell you, okay, this is what it is? I mean, so do you want to just mask it, ignore it, and have it there, and have the LLM aware of it whenever needed, so that it can pinpoint bias in these, in whatever, like in these applications, based on what is being done really by the society, and reflect that. So this is something to consider, and depends on your application. Basically, it depends on the task. Whether it's something LLM to judge biases, you want to have the LLM show you that, or do you want it to reflect that society culture, or or you want, based on your policies, you want an LLM for a given application definitely not to be biased. So I would leave it there for you to think about that.
Perfect. The next question I'd like to direct to Rick Telekdar. The question is, Rick, how might large language models change consumer expectations and behaviors in the coming years?
Yeah. Thank you, Matt, for the question. What I feel is it's going to drastically change consumer expectations as we see innovations all around us. I feel from my personal perspective, I would see more personalization experiences, which is tailored and curated for customer, be it shopping, be it watching a movie. I do envision actually a state where there would be seamless integration between LLMs, conversations, interactions, and then it will become more intuitive and effortless to interact with this. I also feel there are certain areas where there would be proactive assistance that can be provided, right? Whether it's reminding you of your doctor's appointment, or maybe making assumptions on your behavior and then expect the technology to predict what's going to happen next, and based on that, take responsible actions. I would also assume that privacy and control, as we are mentioning, would be critical aspect. So handling personal data, there would be need for more transparency and control over how the data is being used and consumed. And I think the other key piece would be the multimodal experience that we have been talking about. So this will provide the next generation immersive experience for consumer in consumer tech. Thanks, Matt.
Thank you, Rick. All right, so that was the moderated Q&A. Now I want to open it up to the audience, and I see a question already. Is that John? Tom Coughlin, President, IEEE President. If we can have the microphone.
Test. Big room.
Yes, so my question is, and actually it's one that apparently our award winner today is facing right now, is can we use artificial intelligence to be able to quickly adapt various types of interface devices, software, etc., so that they can work together like HDMI?
Great question. So I'd like to let the panelists speak up if they have the first answer. Maybe Robbie seems to have queued up something.
So I'm not a hardware person, so I don't know about the hardware side. But if the software is exchanging data, the answer is yes. In other words, if there's data of that's mismatched or that is in some odd format without a standardized or regulated port, that's exactly where LLMs in particular can shine in terms of transforming that into stuff that other pieces can understand.
Go ahead. Yeah,
Just,
Michael?
I want to mention, if the LLM has the expertise of the hardware engineer, then they can sketch what you need for that interface and the diagram like an engineer and provide what needs to be done, like through the generative AI, would give you the design as a recommendation. So that's doable if it's trained well with the right expertise.
Michael had a point as well.
Gonna note that we can do some things in hardware as well in terms of adjustment. I mean, that's what FPGAs are all about. So we probably will see over time these devices, even consumer devices, will have both GPUs, CPUs, and FPGAs in them. So allow us to do this kind of hardware modification in addition to, most of it will be in software, that's true. But we're going to have to be flexible on both sides because things are evolving regularly in that world.
Thank you, Michael. To any of the virtual panelists, if you have an answer to Tom's question, please speak up.
Maybe I can add 2 cents to that. I do feel there is there is innovations going as we speak around device interoperability. In fact, there are AI-driven protocols and standards being defined to adapt with these situations. And then I mentioned about federated learning for device coordination. So that's one of the common patterns that we see where devices can collaboratively learn from each other. And then they can tackle sensitive data, as well as they can improve the interaction over time. So these are some of the emerging trends that we would certainly see around the consumer tech space.
Thank you, Rick.
So one thing that I would add is that in the context of agentic computing, what we can do is each LLM can not only take an action, but also write down, this is what I've done. And that is sent to all of the other agents that are participating so they can see, oh, I can see or I can read what just happened. And based on this, I may act. And they are interacting kind of like in a regular team of people.
Perfect. Excellent. All right. Well, I'd like to open it up to any other questions from the audience.
Okay, we got one here.
Yes.
Okay. Back in 1989, I wrote an article about how great it would be to access all this cloud information. And there's already Knowledge Navigator. It all looked so great then. Then I was walking by the LG booth, and it was telling me what's going to happen in my day, how my parents were doing. And all I could think was Stepford Wives. Everybody's business model is being my bestest friend. And they're all fighting over me. Alexa keeps popping up. It thinks I want some music. It keeps annoying me. Ecobee, I have to slap it down to have it stop doing me favors. So we've got a business model trying to capture me, and everybody owns me. Interoperability is a complex thing. The other problem I face is a zeitgeist problem that I tend to think, differently. Let's put it that way. And it keeps telling me, no, that's not the way what everybody thinks. So how do we deal with the downside of these things want to be my friend, want to own me, want to do me favors, and each company wants to lock me in to their, overly eager assistant?
Okay. Thank you for the question. Any comments from the panelists?
Yeah, I guess Let me answer that by asking sort of another question, which is, I remember many years ago, 1996, I was at a conference called WebNet, one of the first WebNet conferences, and one of the questions was, what's the number one application of the internet? And without a hesitation, the panelists answered pornography, and they turned out to be correct. And in some sense, a lot we talk about, and Rick gave this kind of utopian view of driving to work and having the artificial intelligence setting your mood lights and arranging your schedule. But in fact, most of the applications, consumer applications, are about entertainment, about the shall we say non-hyperthalamic part of our brains. And I think that that's exactly what you're getting to, is that what industry, in order to capture you, they are going to appeal to your emotions and to your dopamines, not to your intellectual power. And that is that's a very real issue, and I have absolutely no idea how to stop that.
Michael has a point.
Really will. And push it down and hold. Okay. This is an extremely strong challenge because the fact that the people who are paying for the servers, paying for the GPUs, need to make money or they'll go out of business. And we have to find a balance between privacy that they've been stealing from us for many years and them being able to make money without having 90% of the content given to us advertisement, so that we're totally bored with the tool. So it's a major challenge for industry to find the balance of keeping the product revenue coming without either insulting, taking away privacy, whatever, to the user. And I don't think we're anywhere near solving it. The government, don't ask them, they wouldn't have any idea how to solve it. Go to China and you'll have no privacy. So it is a very, very complex problem, and one which I think we should be looking into in more detail, but nobody has been able to solve it since the beginning of the internet.
Yeah, I'm sorry, Bob, we're coming at the end of time here.
Okay. So we're coming to the end. So I just want to give the microphone to Dr. Michael Condrey to give some closing remarks from this session.
Oh, thank you all. I think we had a very active session and certainly brought up very interesting points. I want to make a few big points that came out here. One is usage. We see that usage is going through the roof. But there's another area of usage I didn't hear in our talks. Some of the remote talks, I didn't hear all the words, but language is that what we speak and work together. It also appears in other things, such as circuit design. And companies like ASML are using LLM models in order to analyze silicon circuits for quality, accuracy, and improvements. And that is going on today. So when you think of language models, you have to go beyond our communication that we use, regardless of which language, and think about other implementations. So it is an extremely growing and great opportunity field. The issue of quality is a very important one. The quality comes from the data, and the data needs to be standardized. If it's not standardized, you're going to have one solution for Microsoft, one solution for Amazon, blah, blah, blah. We've got a major standardization problem. Hopefully, we'll be looking at that this year. Implementation, we've brought up several implementation. You can't have your phone be at the same temperature as an NVIDIA chip because it would burn a hole in your pocket. So we have a balance of how to implement it. It is a very, very good problem for us to look at because we want to maximize the use of the consumer device without having the side effect of burning a hole in your pocket. And I want to reemphasize the value of standards in this. This has got to be tied down before industry invents their own, which is a very important. So I think this is an area of major future for many consumer applications, it'll come in. And one more point, and this was brought up, is that one thing is like ChatGPT, where you say, you know, tell me the latest turkey, and it will come back and go gobble gobble. But as the engine starts to know more about you and your intelligence, and instead of say using ChatGPT or using for LLM for support, instead of giving you stupid answers like, you know, is it plugged in? It'll actually already know your level of skills and take you right to the solution, which will be a future of technical support. So there is a lot of opportunities to use it, particularly as we come to know more about and how to integrate that knowledge of the user into the generation of the application. So I just want to point out that we have had a really excellent session here, and it is a great opportunity for your research to see how the concept of LLM can be applied in multiple ways, including language. Thank you very much.
Thank you, Michael. Thank you, Scott, the terrific panel and all the panelists. We do have a very full program, so we're going to move on. Could you put up the slide, please?
Yeah, we have a next program.
This slide here. Yeah. Just want to let you know what's happening now as we move into the lunch hour. There we go. So the lunch program today is a series of awards that'll start with the Mazoro Book Award being given to Steve Mann, and then we have a variety of other society and publication awards. And at some point during the next hour, they're supposed to bring out